In this video, we're going to be taking a look at a situation where a tire is rotating and we're going to find the maximum force of friction that the tire can withstand and the maximum acceleration of the car as well. So we have a 1,300 kilogram car and it has rear wheel drive, and we're asking what's the maximum amount of frictional force the tires can produce if the coefficient of friction is 0.5. And we're also going to find the maximum acceleration as well. So let's go ahead and take a look at the forces acting on the tire. We have the axle that's spinning, that's going to spin the entire tire as well. So there is some initial torque from the center and then some torque as well from the tire on the road. And we have a few different forces. We have the force of gravity pulling it straight down as usual. And then we have the normal force pushing up perpendicular from the road. And then as the tire is rotating in this direction, it has the tendency to want to try to slide to the left, but if it grips and there's static friction catching, then there is a force of static friction pushing the tire forward. So we have our three main forces there, and our normal force and our mg are going to be the same because there are only two forces along the y-axis, and there is no movement or acceleration on the y-axis, so we could assume that those two are equal to each other. Now, what's going on here is there is a certain force of friction, and the force of friction is equal to mu times the normal force. And the normal force of a single tire is just going to be 1/4 of the mg. So we'll say mg over 4 because there's obviously 4 tires total in a car. So we're just analyzing a single tire at this moment, and then we have a mu value of 0.5. Now, as you can see from our diagram, there's only one force acting along the horizontal axis, which means that is our net force that causes the acceleration in this case. Now, because it is rear wheel drive, it is both of the rear wheels. So right now we're analyzing one tire, but we're actually going to take this value and then multiply it by 2 so we can consider both of those wheels in the back of the car. With that being said, let's go ahead and set this force up with all the numbers and find our net force, and then use that net force to find our acceleration. All right, so we got the two things we were looking for. We found the amount of net force provided from friction. So we found the maximum frictional force. That was the first thing we're looking for. And that maximum frictional force was set equal to m times a. So using Newton's second law, we divided both sides by the 1,300 kilograms, and we found acceleration of 2.45 meters per second squared. So taking a look at this scenario, depending on the initial question, you're going to be doing something along these lines where you're analyzing a single tire or possibly 2 or 4 of them, depending on the type of problem, and then finding your net force and then using that net force to find the acceleration. Now, the key to not having it slip is we want to make sure that the torque from the axle is less than or equal to the torque provided from friction. So if the torque of the axle is greater, so from like the center of the tire, then it's basically making the tire rotate too quickly into the ground, causing too much force, and then the static friction won't be able to catch and rotate that tire. Now, another thing to consider would be this. If you were solving for some type of torque value, remember torque is force times lever arm, which wasn't part of our question, but if you did want to solve for some type of torque, all you would need is some sort of radius or lever arm. We don't have the radius of the tire for this particular problem because that wasn't part of the question, but this would be the force over here, 3185 of this value right here. So if you have the radius of the tire, you can go ahead and solve for the torque. So I hope that was helpful to you. Thank you for watching and listening.